Hi, welcome to the Advanced Math Trigonometric Identities Part B quiz recap, where we take the question in the homework quiz for Part B and modify it, make a similar question, and go over the solution. If you haven't taken Quiz B yet, it's not the same question, but hopefully we'll give you some good ideas. If you have taken Quiz Part B and you didn't get full credit, this might be a good way to figure out where you went wrong. So the example we're going to follow that's similar to this original question will be cotangent squared b over 1 minus sine squared b. So I'll start fresh at the top. Cotangent squared b over 1 minus sine squared b. Okay, so I'm going to take two different approaches on this to show you that you don't necessarily know where you're going on these questions. You're just making substitutions, hopefully, towards a simpler representation. And if you keep doing things that are algebraically correct and follow the rules of the trig identities, you can't really go wrong. You might take a longer path one way than another, but usually you end up in the right place. And in this case, there were two paths I wanted to explore that were equally good. So we're going to start way over here on the left. So the first thing I think I'll do with this one is recognize that there's this trig identity for cotangent. Cotangent of theta is equal to cosine of theta over sine of theta. And you'll notice in this case it says cotangent squared of b. That's like taking the cotangent of theta and squaring it. The result of taking the cotangent of theta and squaring it. And that's equivalent to taking the square of the fraction cosine theta over sine theta. Or, notationally, what we like to write is cotangent squared theta equals cosine squared theta over sine squared theta. So it's important that you feel comfortable with this notation. If you take a trig function and you square the result of taking that function, truly this is the correct way to write that. Cotangent of theta, the whole thing, this piece right here, the whole thing represents the output, the result of taking the cotangent of theta. And if you square that, you're squaring all of this, so hence the parentheses. That's a lot of parentheses to write. You do a lot of squaring typically, so this is a notational shortcut, cotangent squared of theta, which means exactly the same thing as this. So this identity here is exactly the same as this one, and it's based on that definition for cotangent, which is that the cotangent of theta is equal to the cosine of theta over sine of theta. So let's take this identity and apply it to the cotangent squared of b and rewrite this expression. So cotangent squared of b is equal to cosine squared b over sine squared b. And we're multiplying that by 1 over 1 minus sine squared b. Now it's super important at this stage that I make sure I put parentheses around that denominator, because it's that entire denominator that's getting multiplied by sine squared b here. So again, we have two fractions, this fraction and this fraction being multiplied together, so we multiply straight across sine squared b times 1 minus sine squared b in its entirety, so we need the parentheses for that. If we don't have the parentheses, this looks like sine squared b times 1 minus sine squared b, and that would just give you 0, which would be really not right. So we need those parentheses. Okay, so at the moment this is actually not looking a lot better than what we started with, but we haven't finished. So we've done the conversion for the cotangent. The next thing we want to look at is this 1 minus sine squared b. Anytime you've got a sine squared or a cosine squared or any trig function squared, you should be thinking about Pythagorean identities. And the simple one that involves sine and cosine goes like this. Cosine squared theta plus sine squared theta equals 1. And it's simply an expression of the Pythagorean theorem for triangles formed in the unit circle. And in the unit circle, the hypotenuse is 1. And one leg is the cosine of theta, the other leg is the sine of theta. So this is a squared plus b squared equals c squared, written for unit circles. And even though we write it like this, it doesn't mean we can't change it into other forms. For example, if I subtract sine squared theta from both sides, we get cosine squared theta equals 1 minus sine squared theta. So this is also a perfectly good expression of the Pythagorean identity. And you'll notice 1 minus sine squared theta here exactly matches the form of this piece of the expression here, which means that we can substitute the cosine squared. So let's try that next. Cosine squared b over sine squared b, just rewriting this fraction on the left, times 1 over cosine squared b. And then, of course, this is really just one fraction. If I multiply across, I'm going to have cosine squared b over sine squared b cosine squared b squared. Okay, so we have a fraction here with a thing in the numerator and two factors, two things multiplied in the denominator. And if we've got a thing in the denominator that's a factor that matches a thing that's a factor in the numerator, we can cancel them. So let's go ahead and do that. Cancel, cancel. And it's worth pointing out that when we cancel this piece in the numerator, we don't just get rid of it. In other words, this is not just sine squared b. By canceling this piece in the numerator, what this turns into in the numerator is 1. So our final fraction is 1 over sine squared b. Now, lastly, what's 1 over sine b? 1 over sine of theta, say, and that's our definition for the cosecant of theta. So our goal, if we can, we tend to favor the sine, cosine, and tangent functions, but if we end up in a situation where we have the reciprocal of the sine or cosine or tangent, we want to go to one of these other functions like cosecant, secant, or cotangent, because we want to get down to as simple as an expression as we can. And, of course, if this whole thing were squared on both sides, we'd have 1 over sine squared theta equals cosecant squared theta. So this just becomes cosecant squared, not theta, no, b. So that's the simplification of the original expression. Now, I said that there's another approach to this, and you might, when you see what I'm going to do, say, well, that wasn't really any different. And fundamentally, it's not any different. In the first case, I worked with the cotangent and converted it into cosine over sine. And then I worked on this Pythagorean identity piece and went to cosine. Anyway, we can do all of those, but in a different order. Works just fine. So instead of expanding the cotangent, let me work on the Pythagorean identity first. So this is cotangent squared b over 1 minus sine squared theta is cosine squared theta. So this becomes cosine squared b. All right. Now, that, nothing I can cancel there. And again, it's really, really important to note that just because I've got a b over b here doesn't mean I can cancel them. It's the cotangent of b. It's the cosine of b. These are not the same numbers. Although the argument is the same, the result of taking the cotangent is different from the result of taking the cosine, and we can't cancel the cosine and cotangent any more than we can cancel those. Okay, so we do have a substitution for cotangent squared, however. It's the same one we used up here. So let's go and write that. Next step, I'm going to put a line down here and keep that separate. A line over here to keep that separate. So cotangent is going to be cosine squared b over sine squared b times cosine squared b. Now you notice I elected not to do this step of having two separate fractions multiplied together, although I could have. I did it slightly more simply and just said, hey, I'm going to go from here down to here. What's important to note in this is that the cotangent squared of b became this part of my expression. And that came from this original piece up here. The denominator, 1 minus sine squared b, became the cosine squared of b, and that's still a cosine squared of b there. Okay? Okay. Now, we've got a fraction with one factor, the cosine squared of b, in the numerator, and two factors, sine squared b and cosine squared b in the denominator. One of those pieces in the denominator absolutely matches the numerator, so we can cancel it. Cancel, cancel. And as before, that doesn't just give me sine squared of b, that gives me 1 over sine squared of b, which, as we saw before, is just the same as cosecant squared of b, which is, of course, our answer. And that's it, folks. See ya.